Hello, welcome to this video on the central limit theorem and an example of using it with means. So we have this scenario here. We have the true average study time, so the population study time for a final exam in history is found to be 6.417 hours, with a standard deviation of an hour and 45 minutes or 1.75 hours. Um, Assume that the distribution is normal, so we have the normal notation right there. So the first question is, what's the probability that if you select one person from the population at random, that they will have a study time of greater than 7 hours? So that's our first question. This is something you could have done back in chapter 2. It has nothing to do with the central limit theorem. So we'd find the z value, x minus mu, which is 6.417, divided by sigma, and that equals 0.3331. So then to find the probability that z is greater than that, so we're looking here and we're looking if 0 is here, 0.333 is right here, and we're looking for that probability. So we'd go to our calculator and do the second distribution normal CDF, put in our 0.3331 to infinity or a large number, and we get 0.3695. All right. So that's a question you could have done in chapter 2 all along. It's just your normal distribution Z problem. Now, instead of the probability of one person, what's the probability that a sample of 4 people has a mean of greater than 7 hours? So that's going to change this problem now, and we have to use the central limit theorem. So for this, with the central limit theorem, that we know that the mean of the population is equal to the mean of the sampling distribution, and we're using a sampling distribution for sample size of 4. So that means all possible samples of size 4, and the standard deviation of the sampling distribution is equal to the standard deviation of the population over the square root of the sample size. So now our Z formula is going to be sigma over rad n in the denominator. So I'm going to go 7 minus 6.417. And now I take the standard deviation, but now I'm dividing by the square root of 4. And that equals 0.6663. So now instead, on our normal curve, we're up here a little higher. So when I put that into the calculator, I get a smaller probability. So now the probability that our sample mean will be greater than 7 is the probability that z is greater than 0.6663, which is 0.2526. Now, if you remember back to the first question where it was just one person for 7 hours, that probability was 0.3331. So our probability went down, and hopefully that makes sense because 7 hours is above the mean, and so therefore getting a mean of 4 people, getting 4 people whose average is 7 hours is less likely than just getting one person whose study time is 7 hours. So getting the 4 people to average to 7 hours is less probabilistic than just getting one person who studied for 7 hours.